Hey everyone, welcome back to this channel. In this video, I just want to go over how to connect up a breadboard. So I've got a couple different resistor values here, and I have a breadboard. So this is our breadboard. The breadboard has these plus or minus rails on either side, sometimes referred to as the power rails. So if you have these power rails, they're going to be connected along their respective line. So this negative rail, all of these little holes are connected electrically. And for this positive line, if we trace it all the way down, all these holes along the red line are going to be connected electrically. And in between power rails, we have just regular, terminal lines. So the rows, right? So row one, this left side is all connected. And then we have a notch. So the notch separates the rows on the left and right. So over here where we have row one, columns F, G, H, I, J, all of these holes on row one are going to be connected, but they're not connected to A, B, C, D, and E. And I have these resistors. So I've got two different values. This one is 470 ohms, plus or minus 5%, with a power rating of 1/4 of a watt. And I don't think you guys have talked about power yet, but once you get there, you'll kind of understand what that means. And this second resistor value is 330 ohms, plus or minus 5%, another 1/4 of a watt power rating. So before you go in and connect your circuit, what you want to do first is draw it out. So let's suppose I just want to look at a resistive circuit, maybe a voltage divider. So start off with one resistor, and I have another second resistor here. And so this is the circuit for a voltage divider. Put this on. And I had these two values, 470 and 330, that I just pulled out. So let's just make this first one 330 ohm, and the second one 470 ohms. So now what we want to do is make our connections. So I'll go ahead and take out one of these 470 ohm resistors. And what we want to do is make this connection, the 330 ohm to the 470 ohm. And we're going to be connecting these guys in series. So we take our breadboard and what I like to do is use up the first row, right? So we go, I'm just going to go into 1C to 1H with my, I guess I use this 470 ohm first. Let's actually use this 330 ohm first here. Let's take one of these out. So I'm first making this connection, the 330 ohm. I'm going to take my 470 ohm out. So from 1 C to 1H, I have a resistor. And we want one end of our 470 ohm to be in the same row as our 330 ohm, right? Because one end of the 330 ohm resistor is tied to one end of the 470 ohm resistor. So I'll just connect this 470 to row 1, column I, and I'll take it down here to row 10, column I. So now what I have here is two resistors in series, my 330 ohm and my 470 ohm. So now what I want to do is take this setup over to a power supply in order to get this voltage source here. So this is what the end product looks like. And I know this seems pretty straightforward, hopefully, but as you begin to make more and more circuits, it's a good reminder to come back to and remember that power lines are connected vertically in this orientation, and the inner terminals are connected horizontally, right? And they're divided up over this notch. So I'm going to take this setup over to the bench power supply now. All right, everybody, so we've come over to our benchtop power supply, and I've turned on this wriggle. And the first thing that we want to do is select our channel. So I'm going to be using channel 1. I click this key, and I'm going to set it up as constant voltage source. So on the left here is a voltage hotkey. I know it's kind of blurry right now, but we select this and we set our voltage. So I'm going to set it up as 1 volt. We hit 1, press this V button up here. And so now it's set up to be a 1 volt constant voltage source. So taking a look back at our circuit diagram here, I've already drawn in this 1 volt, and we're going to apply 1 volt, the positive end across or at this 330 ohm resistor terminal, and the negative end to this 470 ohm resistor terminal. And to do that, we need some wires, right? So the best kind of wire to use in this case, since we have these discrete resistors that we can cling on to, is going to be the banana jack. And so banana to go into the power supply, and then this grabber. So if you hold the grabber like this and you push down, it exposes a little copper wire that allows you to cling on to your circuit. So what I'm going to do is connect our two terminals for the power supply and come back to our circuit. And I'm going to take the positive end of the power supply, cling on to my 330 ohm resistor, and I'm going to take the negative end of the power supply and cling on to the 470 ohm. And if you're having trouble pushing down on the grabber cables, they might be broken, or just keep trying. So some of them are a little tricky. So now I've got my circuit connected, and I'm going to come back over to the power supply. And right now our circuit is not powered, it's not energized. So what we want to do is click this on key. So now our circuit is live and we don't want to be touching any of the wires because there's current flowing through it. And let's just take a step back here and talk about how we want to go about measuring some of those, the voltages and currents. So to measure voltage, we actually don't really need to take apart our circuit at all or really deconstruct anything, because putting the voltmeter in parallel should be pretty straightforward without having to deconstruct our circuit. So we know right here is 1 volt. If we call this, suppose this is ground, then this is 1 volt. At this node, we're kind of interested in what might be going on at this 470 ohm, between the 470 ohm and ground. So I'm just going to call that V out. And this camera is having a really hard time focusing. And so to measure this, we take a voltmeter and we take one end across the 470 ohm and one end across, tied back to ground. So that's how we would measure the voltage. But to measure the current would be a little more tricky. So we still have our 1 volt source. We still have our 300 ohm resistor. But between the 330 ohm resistor and maybe the 470 ohm resistor, we want to put an ammeter. And putting the ammeter here will tell you the current. Putting the ammeter up here will also tell you the current. But the important part is that it needs to be in series with your circuit, right? So let's take a step back to the voltage measurement and take a look at how that might be done. I'm going to take a look at the multimeter up here. We've got our multimeter up here. I'm going to turn it on. It's booting up, and we've got a couple choices. We've got voltage. The voltage key is here, and the current key is here. I'm going to start off with the voltage. And you'll notice on this panel here, we have V, ground, I. So to measure voltage, we want to go into the V jack and to ground. And you'll notice that I'm doing this when the circuit is not energized, which is important because you don't want to shock yourself. So I've got those two, got the red, the positive and negative terminals of the multimeter that is set to a voltmeter. So we want our positive terminal at the junction of 330 ohm and 470 ohm, and the negative terminal back to ground. What I'm going to do is we take red wire going on here to that junction between the two resistors. I don't know if you, well, maybe you can see it better if I bring it closer. So we got the positive end of the voltmeter to this junction, and we're going to take the negative end and go back to ground here. Now, you'll notice that right now we're not reading any voltage, but once I energize the circuit, we're reading about half a volt, or 0.589, maybe 0.6 volts. So I'm going to turn this off now, and let's go over how to measure current. So I turned it off, the voltage drops. And to measure current, we want to take our red lead, take it into the I for current panel. And we go back to our circuit again. And we want the ammeter, the positive end, to be connected to this 330 ohm and the negative end to the 470. So we take off our voltmeter probes and we kind of have to take out this 470 ohm lead in order to measure this, because otherwise we would be putting our current source in parallel. So we take the positive end, tie it to the 330 ohm, take the negative end, tie it to this 470 ohm lead that I just pulled out. See if you can see that better. All right, and so now current is flowing into the ammeter through the 330 ohm and then out the ammeter into this 470 ohm. And if we go back to our multimeter again, we are reading very close to 0 amp. Oh, sorry, got to set this to there. Very close to 0 amps. But then once we energize our circuit, this kicks up to about 1.277 milliamps. So that's how we measure voltage and current and how to connect our circuit up to a breadboard. With that, I'll see you guys in the next video. Thanks.